All right. So welcome to the final video for Unit 1, Part 6, where we talk about two-dimensional figures. And one type of two-dimensional figure is what's called a polygon. And a polygon is a closed figure formed by a finite number of coplanar segments called sides. The sides that have a common endpoint are non-collinear. And each side intersects exactly two other sides, but only at their endpoint. The vertex of each angle is what's called the vertex of a polygon. So each point where there's an angle in the figure is what's called a vertex. And a polygon is named by the letters of its vertices. And we write them in order of consecutive vertices. So here, as you see, polygon G, H, J, K, L, M. Now you don't have to go start with G, but you do have to go in order. So for example, if I started with J, I would have to say J, K, L, M, G, H. But usually you go in alphabetical order. So there are different types of polygons. Like if you have three sides, that polygon is a triangle. Four sides is a quadrilateral. There's different types of quadrilaterals, but four sides is just a quadrilateral. Five sides is a pentagon, kind of like a house. Six sides is a hexagon. Seven sides is what's called a heptagon. Eight is an octagon, think of like a stop sign. 10 sides is a decagon. And then if you just have a big number of sides, like let's say you had 53, you would just call it a 53gon. So once you get after 10, you can just label it as the number of sides gone. Some terms that you need to understand: if a polygon is equilateral, that means all sides are congruent. If a polygon is equiangular, that means all angles are congruent. A regular polygon means it's both equilateral and equiangular, meaning all sides and angles are congruent. Convex means it's a blown out polygon, no indentations. Concave, this would be an example of a concave polygon, where it's like pushed in. That's a concave polygon. So what we're going to do is we're going to look at the polygon, and then we're going to name it by the number of sides and classify it if it's equiangular, equilateral, or regular, and then state whether it's convex or concave. So first of all, number one, you have four sides. So this is a quadrilateral. It is not equiangular or equilateral, because notice the sides are all different. So for that, we would just say none. State whether it's convex or concave. Well, nothing is pushed in, so it's convex. So number two, that is a triangle. Now notice it is equiangular and equilateral, so therefore it is a regular triangle. And it is also convex. So number three, it has 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So 9 sides, it's not on the list, but is actually what's called a nonagon. That would be 9 sides, a nonagon. This does not have any congruent sides. I mean, all sides are not congruent and all angles are not congruent, so we say none. And it is concave because some of it is pushed in. All right, last but not least, this is a quadrilateral. Notice it is equilateral because all the sides are congruent, but we do not know if it's equiangular. And then notice this has sides that are pushed in. So therefore, this is an example also of a concave polygon. So some new things to think about for the next page. Perimeter. Well, perimeter, remember, is the distance around an object. So basically, you're adding all the sides together. Circumference is perimeter of a circle, the distance around a circle. And we'll talk about the formulas. The area, remember, is the amount of space inside of an object. Remember, it's measured in square units, whatever units squared. A square is a quadrilateral with 4 congruent sides, and a right triangle has a 90-degree angle. So, when we talk about perimeter of a triangle, we just add up all the sides. But remember, area of a triangle is 1/2 base times height. The height goes from a vertex to the opposite side and is perpendicular. Square, remember, we add up all the sides, but the area of a square is one of the sides squared. A rectangle, the area is length times width, and the area of a circle is pi r squared, but the circumference is 2 pi r. Now when we compute these, we're going to round our answers to 3 decimal places, unless it's otherwise noted. So for example, for number 5, since this has 4 right angles, this is a rectangle. It's not a square, because remember, a square, all the sides would be congruent. So it's a rectangle, and remember, in a rectangle, the opposite sides are congruent. So this is 4.3 and 8.1. So for perimeter, you add up, you go 4.3 plus 4.3 plus 8.1 plus 8.1, and when you add it up, you get 24.6 centimeters. The area, you multiply length times width, so 4.3 times 8.1, and you get 34.83 centimeters squared. So that's the area, that's the perimeter. So go ahead and try B on your own, see what happens. All right, so if you look, it's a rectangle again. Adding up all the sides gets you 13.8 centimeters. And then the area, length times width, gets you 10.58 centimeters squared. All right, so next we look at a circle. And remember, for the circumference, remember it's 2 pi r. Since the radius here is 8, we go 2 pi times 8, which means it is 16 pi for the circumference, which when you multiply, you get 50.265 meters. Now for the area, remember it's pi r squared, so that means it's 8 squared times pi, which is 64 pi, and 64 times pi gives you 201.062 square meters. All right, so go ahead and try the next one with the circle. All right, so the circumference, remember it's 2 pi r, so 8 pi gives you 25.133 inches. And then area, 4 squared, the radius squared times pi, so 16 pi gives you 50.265 square inches. All right, so next it says Terry has 19 feet of tape to mark an area in the classroom where the students may read. Which of the shapes has a perimeter or circumference that we use most or all of the tape. A square with side length 5. Well, a square with side length 5 has an area of the square with side length 5 has a perimeter of 4 times 5, which means 20 feet. So that uses all of it, definitely. That uses more than all of it. For B, a circle with radius 3 feet, so the circumference would be 2 pi r, so that means it would be 6 pi, and 6 pi is 18.850 feet, so it uses almost all of it. And C, a rectangle with length 8 and width 3, so if you add the perimeter, so you could go 2 times 8 plus 2 times 3, so 16 plus 6 gives you 22 feet. So that's more than what you have. So the answer to the question is a circle with radius 3 uses most of the tape, because the others would need too much. So therefore, the circle is the best choice. All right, so next it says each of the following shapes has a perimeter about 88 inches. Which has the greatest area? Well, remember, for A, rectangle is length times width, so 26 times 18 gives you 468 square inches. So for B, a right triangle with legs of 26, well, remember, that means that the base and the height are both 26. So that means it's going to be 1/2 26 times 26, because base times height. And when you multiply that, you get 13 times 26, because half of 26 is 13, which is 338 square inches. And last but not least, our circle with a radius of 14, remember it's pi r squared, so pi times 14 squared, which is 196 times pi, which gives you 615.752 square inches. So notice the circle has the greatest area. All right. Last, if you look at the picture, it says find the perimeter and area of the Pentagon and it gives you the points. Now remember, to find the length of the side, you have to use the distance formula. So to find, for example, AB, you have to take the square root of x2 minus x1, so 4 minus 0 squared, plus 0 minus 4 squared, which is 4 squared plus 4 squared, actually negative 4 squared. But basically it's 16 plus 16, which is the square root of 32, which the square root of 32 comes out to 5.657. So that's the first one. And it's just units, sorry, because it doesn't tell us. It's just units. BC, So we'd have to do the same thing. So we go 3 minus 4 squared plus negative 4 minus 0 squared. So it's equal to negative 1 squared plus negative 4 squared. So it's equal to the square root of 17. And the square root of 17 is equal to 4.123. And then to go from C to D, we'd have to go negative 3 minus 3 squared plus negative 4 minus negative 4 squared. So we get negative 6 squared plus 0 squared, which is the square root of 36, which is 6. And then we go ED. Well, now if you notice, ED is straight up and down, so we could count instead of doing the distance formula. It'd be 1, 2, 3, 4, 5. We could have done the same thing for CD and gotten 1, 2, 3, 4, 5, 6, which we gotten. So ED is 5. Last but not least, AE. We have to do the distance formula. So we'd go negative 3 minus 0 plus 1 minus 4 squared. So it's negative 3 squared plus negative 3 squared. So it's equal to the square root of 18, which, when you calculate it, is equal to 4.243. So when you add them all up, so you go 5.657 plus 4.123 plus 6 plus 5 plus 4.243. That's the perimeter, and that equals, so that equals 25.023 units for the perimeter. Now, as far as the area goes, well, we could make this into a couple different triangles. Notice we could make it into, so we make it into a triangle there, and then we make it into a triangle here, and then we have a rectangle there. So we'd have to find the area. So this is the first area, there's the second area, and then the rectangle would be the third area, or it might be a square. So, but I think it's a rectangle. So to find the area, so area 1 is a rectangle, right? And notice the height is 1, 2, 3, and the base is 1, 2, 3, 4, 5, 6. So you go 1/2 6 times 3, so that's equal to 1/2 of 18, which is 9 square units. The second area, well, the height is 1, and the base is 1, 2, 3, 4, 5. So we're going to go 1/2 of 1 times 5, which is 2.5. And then third, we have the rectangle, because it's 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5. So it's a 6 by 5 rectangle for the third area. So you just go length times width. which is 30 square units. So if you add up for the area of the Pentagon, it's 9 plus 2.5 plus 30, which is 41.5 square units. All right, this concludes part 6 and unit 1. So I hope you enjoyed the videos, and if you have any questions, please feel free to ask. Have a good evening.